All right. So yesterday we talked about end behavior, and we've also talked about domain, range, and intervals of increase and decrease. The last thing that we've got to talk about is how to tell whether or not your function is even, odd, or it could be neither. Okay, so we're going to talk about how we can tell whether it's even, odd, or neither using both graphs and by just looking at the equation. Okay, so if we're just going to be looking at the equation, we can tell whether it is even, odd, or neither by saying a function is even if all of the exponents of the variable are even. Okay, a function is odd if all of the exponents of the variable are odd. And a function is neither if the exponents are a mixture of odd and even. Okay? So just going back over it, if you look at your function and you look at the exponents, if they are all even numbers like 2, 4, 6, 8, 10, then you know that that function is even. If you look at your function and all of the exponents are odd, like x to the 1 or just plain x, that would be considered an odd one. Okay, but we have to be aware of constants. All constants really have an exponent of 0 because x to the 0 power is always equal to 1. So if you ever have a constant, then we know that its exponent is really x to the 0. Okay, so x to the 0 is even, always, always, always. Okay? So if we're looking at a graph, a function is even if the graph reflects across the y-axis, meaning you could fold it hot dog style and it would match up. Like if you were to fold your graph directly across the y-axis, fold it skinny ways, then that graph would land right on top of each other. You could draw a line right down the middle, slice it in half. A function is odd if the graph has 180-degree rotational symmetry about the origin. Okay, that doesn't make a whole lot of sense. But what that means is you could turn that whole graph upside down and it would look the same. It just must go through the origin. So you could just flip it upside down, and if you still see the same graph, then you know you've got it. But the only thing you have to remember is it has to go through the origin. Okay, so if we were to look at this one, example 1, if we were going to say is it even, odd, or neither, what you're going to do, go down through this right here. We see if we fold it right across this y-axis, if we fold it over, right there, then that is an even function because you could fold it over and the two sides would land right on top of each other. Hot dog style, it's even. All right, this one, if we were to flip it upside down, and it does go through the origin, let's see. This is x to the 3rd minus x to the 1. Look at my exponents. They're both odd, so that would make me think this graph is odd. All right, now this one, it does not go through the origin. It does not go through the origin. So we're missing that part. So can it be odd? Nah. That one's neither because it doesn't go through the origin. It's not even because we can't fold over the y-axis. All right, so let's look at algebraically, just looking at an equation. We don't have a picture this time. So if, excuse me, if we're going to go through and look at my exponents, I've got x squared and then I have a constant. But we had to remember something about constants. Remember, constants have a x to the 0 power. Okay, now then we look at our exponents, x2, x0. 2 and 0 are both what kind of numbers? They're both evens. So that means that this graph would be an even function. All right, let's look at number 5. Check out my exponents. Okay, I've got x to the 4th, and then I've got -3. Uh-oh, got to be careful. I got a constant right there. So that constant's really got a x to the 0 power. So I've got x to the 4, and I've got x to the 0. 4 and 0 are both what kind of numbers? 4 and 0 are both even numbers. So that means this function must be even. All right, let's look at example 6. Okay, looking over here, I've got x to the 3, and then I got just plain old x. Well, that exponent here, if there's nothing there, isn't it understood 1? So then I just look at my numbers. I've got x3 and x1. Well, 3 and 1 are both what kind of numbers? They're both odd. So that means this must be an odd function. All right, so now we just look at these. All right, f of x equals negative x to the 3rd. All I have is x to the 3rd, so that must be odd. What about 5x to the 3rd? I've only got one exponent. Must be odd. Ooh, what about this last one? This last one, x squared plus 4. Well, 4 doesn't have a variable, but we got to beware because it's a constant. So since that's a constant, what was our variable that it had to have? It had to have x to the 0. So 2 and 0 are both what kind of numbers? They're both even numbers. So that means this function must be even. All right, so going back to my graphs, okay? Remember with my first graph, let's check for symmetry. This one looks like we might have folded across the y-axis. So if we look at that one, as we fold it across the y-axis, would it land on top of itself? Sure would. So that one must be even. Now looking at my one on the right, okay, first of all, I check for the origin. Definitely goes through the origin. And then if I were to flip that thing upside down, would it land on top of itself? It sure would. Remember that origin is very, very important. So now you're going to finish the rest of your classwork.